Let me welcome you to the 21st lecture of NPTEL online certification course Underground Mining of Metalliferous Deposits. We are discussing about the underground developmental works and particularly the horizontal drawbages. This is the fourth and final lecture of the horizontal drawbages, but before continue with this lecture, let us look into the learning background required for the participant of this course. These are the learning objectives set for this course, and this is the expected learning outcomes from the participant of this course. These are some of the text and reference books, and these are the learning objectives set for this 4 lecture of horizontal drawbages. To understand the construction method of horizontal opening, namely drift, drawbage, crosscut, edit, etc. To learn different unit operations associated with construction, and to understand the factors affecting the choice of construction methods. So far we have seen the construction methods are divided in 2 parts. One is drilling and blasting method, and another is mechanical cutting method. In drilling and blasting method, we have discussed how the drilling and blasting is carried out for the discrete excavation of the tunnel, then simultaneous loading and transportation and other supporting and auxiliary works. In mechanical cutting, we have found there are 2 machines, TBM and rod header, though TBM is not a very popular machine in mining sector and not used because of some of the problems. Another machine, which is rod header, can be used in the underground mines as the cutting machine. Here also we are having 2 options, either we can use this cutting machines along with the simultaneous loading and transportation, or we can have the discrete loading and transportation along with this. So, we can have all these different activities, and we have seen this is the rod header. TBM we have already discussed in the last class, and in this class we will discuss about the use of rod header for the construction of the horizontal drawbages. We can see the rod header. Whenever we are using rod header as the cutting machine or excavating machines in the rock, the rod header can be matched with a shuttle car or low profile dump truck to take the cut material from the rod header and can dump that to the suitable transporting system, or rod header can be directly coupled with the conveyor belts or chain conveyors, so that it can discharge the material onto this and the continuous transportation system can be adopted, or rod header can be matched with the mine car, where a series of mine car will be placed and those mine cars can be filled with this rod header, conveyor of the rod header, that can be also adopted using the rod header system. These are the transporting system. Now, let us see how the rod header is working. Rod header is most widely used underground partial phase mechanical excavator. Now, this point is very important. We have seen TBM. TBM, the excavation is carried out for the full phase. So, it is a drilling machine. The complete phase is excavated by the TBM. So, the phase size for TBM phase size is equal to the TBM size, but rod header is not the same. Here the phase size is larger than the size of rod header. So, that is why it is called a partial phase mechanical excavator. The excavator operating, it excavate a part of the phase and gradually that part is extended for the whole phase. So, that is why this is a partial phase excavator. Rod header was first developed in 1950s for the excavation of the coal. In fact, till date continuous miner, which is a similar machine of the road header very commonly used for the excavation of the coal. And gradually the machine which are adopted for the coal, that is made for the softer formation, is modified suitably for the hard rock excavation, mostly for the civil projects. And nowadays road header is 1970s onward very commonly used to excavate haulage, drifts, roadways, crosscut in underground metalliferous mines. So, 1970s, before 1970s it was mostly adopted for the civil projects apart from the coal mining, but 1970s onward the sufficient modification of the machine is made to use the machine for the hard rock excavation also. Now, let us look into the different parts of the machine. Road header is commonly having a cutter head. The cutter heads are equipped with a point attack tool. Point attack tools, those are equipped in the cutter head, and that is forming an array, or the pick lacing is made such a way that it should be suitable for cutting and following the cutting angles, following the rake angles that can be maintained for achieving the best production. Then there is a telescopic boom which can move in front and direction, as well as there is another provision is given where the the telescopic boom can be rotated in any direction also. The boom is supported with a supporting arm, then the hydraulic motors are available, pumps are available, and this is the important part is that there is a gathering arm is automatically provided in the road header. So, while the cutting head is cutting the material, the cut material is coming and dropping in front of the scraper plate, and this scraper plate is basically taking this material in its plate, and this gathering arm is allowing or guiding the material into the chain conveyor provided here. The chain conveyor is taking the material and guiding the material to the discharge conveyor. Often a road header is equipped with a small storage space, so that the gathering arm can store the some of the material in its storage place, and in case of the non availability of the mine car or the LPDT, the material can be stored there, and when the mine car or LPDT are coming to the close to the machine, then the discharge conveyor discharge the gathered broken rock from the storage place to the transporting medium. So, road header is a hybrid mechanical excavator, consists of a boom mounted rotating cutting head with a conveyor for broken rocks. The machine is crawler mounted and mobility is high, advance rate is good, and it is applicable for soft to medium hard rock. In fact, basically the hard strength of the rock guided the performance of the machine. Soft material the performance increases, hard material the performance decreases. Road header is basically classified in two groups, one is a milling type, another is ripping type, and also road header is often specified with its weight. We will discuss why this weight is important. It is a light road header, medium size road header, or heavy road header, basically considered in three ways. Let us first look into the milling type and ripping type road header. This is called milling type road header, where this boom is rotating and the cutting picks are attacking the rock and dislodging this one, and here it is a ripping type where the boom is rotating and attacking the rock in its front, and that is excavating the rock or dislodge the rock from it. The main difference is that this is attacking the tool in its front, then it is guiding towards side. So, basically it is creating an opening, then it is extending the opening in the side, and that is why this is milling type rod headers are shown in this place. And both the cases excavation can be seen. Here the excavation, these are the real pictures, and this is the milling type, this is the ripping type rod header. Now, let us look into the operation of a rod header first. So, you can see this is a milling type rod header. So, this is the gathering arm, this is the crawler. So, as this cutting head is rotating, it is basically stacking the wall and cutting. So, you can see the cutting is started. As it is rotating, this point attack tools are striking with the wall rock and dislodging the rock. So, you can see, and this is waters are spread on this, so suppress the dust. So, you can see it is not that much dusty, though the cutting is going on. So, as this is cutting, so this is now cutting the, it is in a coal mine, and you can see now this is the gathering arm. You can see this is the gathering arm. You can see as the material is being cut. So, gathering arm is guiding the material towards the chain conveyor. You can see the chain conveyor was there. So, it is guiding the material towards the chain conveyor. And chain conveyor is dislodging the material to the main conveyor and to the discharge conveyor, and discharge conveyor is dislodging the material to the main conveyor on which the material is transported. So, in this case it is a continuous transportation system, continuous cutting, then the cutting material is basically guided towards the primary chain conveyor. So, the primary chain conveyor is taking the material, you can see the primary chain conveyor is taking the material to the discharge conveyor, and the discharge conveyor is discharging the material onto a conveyor. So, you can see discharge conveyor is discharging the material onto the conveyor. So, this is a very common system in the rod header. Now, rod header performance depends on the rock parameter. These are basically strength properties, discontinuity properties, abrasivity, etc. Machine parameters are also governing. Machine weight is an very important parameter. Cutting power, that means the rotary head rotation power. Cutting system, whether it is a milling type, ripping type, water assisted, not water assisted, that is considered in the peak cooling system. The peak configuration, the array in which the peaks are placed, these are very important here. Now, in this case, first is that weight. Why weight is very important here? Because weight is basically giving the normal force. As the weight is very high, the normal force provided to the cutter head is very high, because weight is resisting the machine to move in the backward direction when the force is applied. So, that is why it is increasing the normal force. That is why this weight is very important. So, hard rock condition generally heavy duty rod headers are used, which are of 80 tons or so. Cutting power is the rotary cutting head power, the speed of the rotation basically gives the more drag force to that. So, that is why cutting power, and cutting system is important for milling and dripping type systems. These are very important, and peak configuration is basically how much is the cutting angle, how much is the rake angle, how much is the wedge angle. These are very important while the cutting operations are considered in that case. Last and final sets of parameters are sight parameters, that is the cutting direction, whether the cutting is towards the foliation or towards the bedding direction of the bedding planes or against the direction of the bedding plane. Then the peak cooling arrangements are very important. If you are not using the water, the peak will be hot and its performance will be lost, and the operator skill is another important. And based on these three sets of parameters, performance of a rod header depends a lot, and based on the performance we have to choose the types of rod header. These are the different formula given by different researchers. Bill Jin has given this formula, who is a very pioneer person in working in the performance of the rod header. Cooper has given, Uday and they has given. These are some of the formula in which some of these influencing parameters are considered to predict the performance of the rod header. So, let us solve one problem based on this formula. Suppose a rod header is deployed whose for an underground drift with the rock compressive strength of 120 MPa and Brazilian tensile strength of 10 MPa. Weight of the rod header is 80 ton and the power of the rod header is 400 kilowatt. Then determine the cutting rate of the rod header using the Cooper's formula. So, let us look once again into the Cooper's formula. So, this is the Cooper formula which can be used for prediction of the performance of the rod header. So, if we are using this formula, we can find that cutting rate is coming around 50 meter cube per hour. So, remember this is instantaneous cutting rate. Instantaneous cutting rate as the loss hours are not considered in this case. So, this is instantaneous cutting rate can be calculated using this formula. Let us solve another problem of the rod header. Suppose a mine has two loads, vein A and vein B. Strike length of vein A is 700 meter and vein B is 1.8 kilometer, that means 1800 meter. Vein A is having a width of 5 meter, vein B is having a width of 8 meter. Now, conventional ore drives are driven in both vein A and vein B. There is no drift, only ore drives are there, and a cross cut of 200 meter from the shaft to vein A and another cross cut of 350 meter from the vein A to vein B, that is the extension of the first cross cut, has to be made, and those are considered 4 meter width. Why this is considered 4 meter width? Because 4 meter width is essential for our plying of the largest size machine. So, that is why the 4 meter width of the rod heads are considered here. Now, we have to deploy a rod header which has an average capacity of 25 meter cube per hour. So, this 25 meter cube per hour is considered the capacity of the cutting of the road header, considering the 50%. In previous case we considered the 50% efficiency of that is considered there. Now, we are also finding that the monthly utilized cutting hours are the 250 hours. Now, the excavation height required for all the cases is 3.5 meter. Again, considering the largest plying machine, we consider the 3.5 meter, all the openings should have that height. Then we have to find out what is the developmental time for that particular level, so that the level development will be complete and we can start our excavation in that case. So, let us understand this problem. Say this is our shaft, there is a 200 meter cross cut from shaft to vein A, and there is a 350 meter cross cut from vein A to vein B. Vein A is 700 meter long, vein B is 800 meter long, and vein B size of opening is 8 meter width. So, we will not leave any ore there. So, complete width has to be excavated. So, the width of the drive is 8 meter and 3.5 meter is the desired height required for the plying of the machine. In vein A, 5 meter is the width, because the ore width is 5 meter, we will not allow to, we will not leave any ore there. So, we will extend our width of the drive is 5 meter and 3.5 meter is the height required. And this is cross cut which is in the waste rock, and that is why our dimension is fixed 4 meter by 3.5 meter, because it is the dimension required for the machine size. So, these are the excavation we have to carry out in this level. So, what are the excavation? Excavation is this one means 200 plus 350 by 4 meter by 3.5 meter. Then this one, this is into 1800, and here. So, these are the excavation we need to do. So, from there we will get the volume of excavation required. So, let us see the solution. The strike length of load A, load B, then width of excavation load A, load B, cross cut length and width of cross cut, height of all, road header performance is given 25 meter cube per hour, and monthly available utilized hour is 250 hour. So, the volume of rock to be excavated in the cross cut is 200 plus 350 into 4 meter into 3.5 meter. So, that is coming this one. Now, volume of rock in load A, that is 700 into 5 into 3.5. So, that is this much, and in load B, which is 1800 into 8 meter width and 3.5 meter. So, that is coming this much. So, the total volume of rock to be excavated is this much meter cube, 70,000 meter cube. Hourly excavation is 25 meter cube. So, the hours required to excavate is 2800 hour. Available hour per month is 250. So, we need close to 11 month time is required to complete the excavation of the complete level. So, you can see road header is a very good equipment that cut the material continuously. That is why the performance are better than the drilling and blasting. Obviously, it is less than the TBM, but road header does not need a long time of installation. So, it does not need a long time of installation like TBM. So, that is why just like any drill machine etc., road header can be deployed very easily. Road header can be combined with the low profile dump truck, with the mine cars, with the conveyor belts, chain conveyors etc. So, that is why road header can be easily deployed in any mines without any notice. Obviously, price of road header is little bit higher. So, that few crores rupees are required for procurement of the road header, but that is very much manageable with the mining industries, and this gives us the well acceptance of the road header as the most common equipment of the horizontal excavation in the mine. The small size of the road header allows this mantling, dismantling as well as the movement between the one level. So, if the level operations are carried out, so if the level operation is complete in level 1, the same machine can be further deployed to level 2 for completion of the horizontal excavation in these levels. So, that is why road header is one of the most common and popular machine that is adopted in the horizontal excavation in the most of the metalliferous mines. So, this basically concludes the excavation of the horizontal drivages. In fact, the incline or vertical excavations like raising, winching will be covered in the next lectures. There will be 4 lectures on raising and winching also. So, this will conclude the excavation of the horizontal drivages. We have covered drilling and blasting method, excavation by road header and excavation by TBM as the future scope of development in this sector. Thank you.